Okay, so in this lesson, we do a consolidation of everything trigonometry that we have learned. It's important to understand that trig carries a lot of marks. So you can see here, look at this is 30 marks. 30 beautiful marks that I need you to claim and clean. So we're going to break it down so that we don't get bored. Okay, so if you see my roll call today, we have a trig function, we have a 2D. Okay, so we're going to break it down. Let's break it down into 4. So guys, quickly, 5.1 and 5.2 will be what I would need you to quickly handle for me. How many marks? 9 marks. 9 marks. We have 7 minutes. You may start. So this is reminding us of everything trigonometry. Let's see what you remember, and you would learn a few things here. 9 marks, I said 7 minutes. Let's make it 7:40. There we go. Remember how to do your quadrants and all of that. All right, were you able to do the first two questions? Thumbs up, thumbs down. Please give me a quick response. Thank you. I see those thumbs, big fat thumbs. Okay, so in case you have forgotten, this is where we'll learn now. So we're going to run through all of these questions now. We're given that if negative 310 beta minus root 5 equals to 0 and sine beta is less than 0, determine the value of that with the aid of a diagram. That's where the key is. With the aid. So the first thing I'm going to do is to simplify that. And this also is in your grade 12 paper. So I have negative 3 tan beta minus root of 5. Okay, so negative 3 tan beta equals to root 5. Divide both sides by that. What are we going to get? Negative root 5 over 3. Question: where is tan negative? I'm hoping you remember your quadrants. That all students take coffee. So I am seeing a tan as negative. Where is tan negative? It's quadrant 2. So tan is negative in quadrant 2 and quadrant number 4. That's the first information I'm able to retrieve from that whole thing. The second one, examiner now gave me that sine beta is less than 0, which means sine beta is negative. Where is that happening? Let's go back to our quadrant. It's quadrant 3 and quadrant number 4. I hope you remember that. 3 and 4. I am going to look for what is common. Quadrant 4. So my diagram should be in quadrant number 4. And that is the shape of my quadrant. And that angle becomes beta. That is very, very important. Then I'll go back to tan beta. What does tan beta mean? Tan beta is y over x, or what we know as opposite over what? Adjacent. Okay? Opposite over TOA. So my opposite is the negative root. Okay, it's root 5, but I can see that it's negative root 5 because it's below. And my x is 3. Perfect. My x is 3. Please, you need to stop me and ask me questions wherever you feel lost. The thing now is I don't know my r. Theorem of Pythagoras, r squared equals to what? X squared plus y squared. What is our x? 3 squared plus negative root 5 squared. What would that be? 9. If you put that in your calculator, you'd have a positive 5. And that will give you r will be the square root of 14. R is the square root of 14. Let me see thumbs up if you are still on the same page with me. We are still on the same page. Beautiful. Now, the examiner wants me to find sine squared beta minus cos squared beta. One thing I need you to know quickly is this. You must know that sine theta or beta is y over r. Cos is x over r. Once you know this, life becomes very easy. And tan theta is y over x. So I can use that. This is basically y over r all squared minus x over r Okay, what is my y? My y is negative root 5. Please, you need to put the signs. Over root of 14 minus, what is our x? 3 over what? Root of 14 squared. This would give you 5 over 14 minus 3. No, minus 9 over 14. You can use your calculator to confirm. 5 minus 9, negative 4 over 14, which is negative 2. Did anybody get negative 2 over 7? Okay, negative 2 over 7. Is there any question you would like to ask here? You are lost somewhere. You need guidance. Please, 5 marks is in the bag. If there is no question, we carry on. What I'm going to ask you to do, for every screen, so we don't waste time, somebody take a picture and send it through. Take a picture and send it through quickly onto the group. Thank you, Michelle. Beautiful. So for every slide, we do that. Now, quickly, let's look at 5.2. How to reduce. Very, very important. So this would be, guys, you would need this lesson again at the end of the year when you write. You would need this lesson again in grade 12 when you write. That's why some grade 12s are in this lesson as we speak, because this is tested as well. So please, I'm trying to show you the importance of this. Okay, given that cos 49 equals to k. Now, quickly, what the examiner is trying to tell you is that cos 49 degrees is actually k over 1. Let's see if we are going to need any of this, the diagram maybe. What is sine 131? I know you guys want to do what you guys are used to. 131 is in the second quadrant, so it's going to be sine 180 degrees minus. You just pick your calculator and say, what is 180 minus 131? But I don't do this, okay? 49. But because it's in the second quadrant, remember, second quadrant, sine is negative. And learners forget all of those things. So this is something as negative sine 49 degrees. I really don't do this. Okay. The question is, how do I get that 49? Look at what I do. I just use my calculator, and I'll show you quickly. I showed you last week. I'll go to my calculator. Let's see if we're going to get the same answer. Sine 131 equals to. Okay, I'm not going to write that down. I'm going to reverse the answer by saying shift sign of that answer that I got. 49. Oh, sorry, second quadrant, sign is positive. 49. Can you see my sign 49? I'm done. That's where the mark is. 1 mark. So all this 180 minus really doesn't fetch you a mark. But here is my problem. I have sine 49. The examiner gave me cos 49. Remember where we came from. What is cos? Cos is x over r. But sine is, I do not know my y. I need to run to theorem of Pythagoras quickly, because I'm going to need the y. What is my r? 1. What is my x? K. And I don't know the y. Move that over there. 1 minus k squared. So what is y? Y equals to root of 1 minus k squared. So I can then complete my job to say sine 49 degrees, which is y over r. What is my y? Root of 1 minus k squared over 1. And that will be my answer. You'll get a mark for sine 49. That should be actually 3 marks, but they're trying to be stingy in this paper. And my second question, that's very straightforward. 5.2.2. 1 minus cos squared 41. 1 minus, oh, hold on. It's not so straightforward. They are giving me cos 41. Okay. They are giving me cos 41. What is cos 41 going to be? That's my question. Now, guys, quickly, let me show you something here. I hope you remember this, that sine squared a plus cos squared a equals to 1. Check that. There are two things that I can do here. This is one of them. I want 1 minus. So sine squared a is 1 minus cos squared a. Do you notice that this is what I have? Therefore, 1 minus cos squared, this is one way of doing it, is the same thing as sine squared 41. All right, sine squared. If you were to draw, you would actually see sine 41 coming up. But I want us to learn the way of doing maths. What is the relationship between 49 and 41? Always check. Do you notice that 41 plus 49 would actually give us 90 degrees? Which means these two angles, I can use cofunctions. We are revising, so I'm going all out. It means that sine 41 is the same thing as cos 49. But there's a square there, so there's a square there. Therefore, I can conclude that, let me write the whole thing again. 1 minus cos squared 41 is the same as sine squared 41. But sine squared 41 is the same as cos squared. We keep the squared, 49. And what is cos 49? K. So this is what? K squared. This is one way of doing it. I don't know if it makes sense. And I wanted to go this way just to remind you of some of the important points. Please talk to me. Let me know if it makes sense. And we also ask questions, please. So I used cofunctions, I used the quadrant, I used the identity rule, sine squared a plus cos squared a. Just reminding us of everything trigonometry. Okay, all good? No questions? Send a picture, please. Send a picture, please. Thank you. Okay, next, guys, I'm going to move a bit fast. If you need the notes are being sent on. Make sure you copy it. Oh, look at question 5.3. What a beauty. 7 marks. What a beauty. Please get me those 7 marks and you have just 4 minutes. What a beauty. 7 marks, you have 4 minutes. Hi guys, were you able to finish? Who's talking to me there? Okay, why are you delaying?
I'm the last step now.
Okay, you continue, I'll start. Okay, guys, if you use my method, you'll be fast and you'll get this right. Do you remember my method? I did this last week again to remind you. I have a 0, I have a 90, I have a 180, I have a 270 degrees, and I have a 360 degrees. Use my method and you'll find things very easy. If you are moving this way, no change. If you are moving that way, vertically, you change. So here, we're saying no change. Here, yes, you change the trig ratio. And your sine would become cos, your cos would become sine, and your tan would become 1 over 10. And then you use your theta as 1. Anyway, you see theta, put 1. Done. First one, tan 180. 180, I am moving, 180 is on the horizontal, so it's not changing. So that leaves me with 10. If you are not sure, just get a calculator. You're looking for the sign. It is 10, 180 minus 1 because it's minus x. Check. It's a negative sign. And that makes sense because it's in the second quadrant. But I'm not even using quadrant. It's negative. So negative tan x. I already have 1 mark. If I lost you there, find me in the second one. Cos negative x. There's nothing in the bracket, it's a 0. So where is my 0? Oh, it's here, no change. So it remains as cos. I am not sure now whether there's a positive or a negative. I'll come here and say negative 1. Definitely it's going to be a positive answer. Check. Lovely. I'm done. It's not changing and it's a positive cos x. I have my second mark. Sine squared 360. Anytime I see a squared, it's always positive, right? Because even if it's negative, it will be negative times negative. So check. 360 there. Where is 360? Oh, there. No change. So it remains as a positive. All right? And because it's x, it becomes sine squared x. It remains a positive. Cos 90, beautiful. Where is 90? 90. Oh, it's up and down. So yes, change. Your cos will become sine. Beautiful. The next thing I'm going to ask myself is it a positive or a negative? I'll use my calculator. 90 minus 1, positive answer. So I know this is a positive and cos becomes sine because of the vertical move up and down. Over, by the way guys, I am already sitting on 4 marks. Sine 180 minus x. 180 is under no change, so it remains as sine. And that's your second quadrant, which is positive. But let us confirm if it works. Sine 180 minus 1. Check that. It's positive. Lovely. I am sitting on mark number 5 out of 7. The rest is about simplification. Yes, talk to me. There's a hand. Rose? Sorry, Rose, a bit louder. Which one? It's not. That's what I said. Okay, let me show you that if it is positive, look, sine squared 360. Once I see a squared, it becomes positive. It simply means sine 360 minus x multiplied by sine 360. They are both in the fourth quadrant. So this alone would give me negative sine x multiplied by negative sine x. What is negative times negative? Positive.
Okay.
So anytime I see a squared, automatically it is a positive. Yes, next question.
Are we not plussing sine squared x and not multiplying it?
Oh, there's a plus there, sorry. That's a plus. That's a plus. Lovely. Beautiful. So, let's now change. What is 10? It is negative. And please, if I see negative 10, don't write the negative twice. It's just one negative. Multiplied by, guys, the way we write as well will affect us. Plus sine squared x multiplied by what? Sine. Now look at it. My denominator is 1, which I can split if I want to do it this way. I can do that. Algebraically is correct. Look at this. Ta. And if I don't do it like that, I can factorize. Okay? Let me do the factorization one. Let me go the factorization way. But this is also correct. So I have that. So what do I have? Negative sine x plus, okay, I'm not going to multiply that out because I see that sine x will be common. What's common at the top? Sine x is common. What do we have? Negative 1 plus sine squared x over sine x. So my final answer becomes, check, sine squared x minus 1. But the examiner said a single trigonometric ratio. We go back to, once I see sine squared, grade 11, cos squared x plus sine squared x equals to 1. What is sine squared x minus 1? Let's do the maths. Very simple. If I move that there, I'll have sine squared x. Then the cos x goes over, it becomes negative cos squared x. So my answer is negative cos squared x. Are we okay? Talk to me. Picture, please. Any question? Picture, please. Thank you. All right, guys, the lesson will be available. Please rewatch because I want us to cover a whole lot. Oh, 5.4, another beauty. Let's see, do I have enough? Yes, 5.4, 5 marks. Come, my good learners, without using a calculator. I love this. 5 marks. I'll give you 5 minutes. Without using a calculator. Come, there we go. I added 40 seconds extra. Okay, guys, how do we solve this question without the use of a calculator? Okay, let's see what to do. First, I notice that I have a 15. So what is sine negative 15? If I go back to my calculator, which I'm going to use to show you how to quickly walk through this, look at this. I am seeing something. I'm seeing a negative answer. All right. And so that means my sine negative 15 can be written as negative sine 15 multiplied by cos 75. Now, what is tan 75? It is sine 75 over cos 75 multiplied by cos. Now, what is cos 165? You must know how to reduce quickly. It's in the second quadrant. Cos 165, I told you what to do. Shift cos answer. Now, it's going to give you that 165 again. And I taught you what to do last week. Minus 180 would simply help you. And that is negative 15. So that's negative cos 15. Okay, that goes. Let's simplify. What do I have? Negative sine 15. I want you to see something here quickly. Let's put our degrees. Now, what do I have? Plus sine 75 degrees. Oh, it's going to be a minus now because we're multiplying, remember? Positive times negative. Okay, cos 15. For those in grade 12, they can start working with compound angles. But for us in grade 11, we're not doing compound angles. But the first thing I'm going to realize again is that 75 and 15, if I add them together, that will give me 90. So I'm going to bring in co-what? Functions. So let's change everything to 75. It means negative sine 15. Sine 15 can be written as cos 75. I have this as cos 75. I want us to write everything as 75. And what will this be? Sine what? 75. Okay, what do you have? Oh, this is so beautiful. Cos squared 75 minus. Let's take out the negative. What do we have? Cos squared 75 plus. Oh, this is lovely. Cos squared A plus sine squared A is 1. My answer is negative 1 without the use of a calculator. Do you see what I did there? Do you see what I did? Okay, please take a picture. Again, you'll be able to rewatch because I want us to cover every aspect. So don't forget, once they say without the use of a calculator, co-functions come in a lot. And where do you get co-functions from? When the examiner gives you two values that are complementary. Thank you, Sitley, thank you, Michaud. 5.5. Oh, proving identity. Then we do general solutions. Do I want you to do both of them at the same time? I think we can have 10 minutes to do both. Prove identity and the general solution. Let's try it for 10 minutes. You got to run. Both questions, please. Okay, let's race on these two questions quickly. Prove the identity. Always start from the complex side, and I see that the complex side is the left hand side. So left hand side. I have 3 cos x over 1 plus sine x. Now I'm going to change, the only thing I can do right now is to change that 10, and it will be 3 sine x over. Guys, the common error is Elena is writing the 3 twice. No, the 3 is only written once. Now, this is why you must know algebra, how to deal with fractions. Diagonal, diagonal, denominator. I'm going to multiply across there. That will give me 3 cos squared x. I'm going to multiply across here. There's a plus in between. 3 sine x into 1. I hope I get an answer. Over. Then I am going to multiply my denominator. So it's diagonal, diagonal, and denominator. 1 plus sine x. Let's see. That's what I'm thinking. But let's see if it's going to work. So what do I have? 3 cos squared x. Expand. 3 sine x plus 3 sine squared x, okay, over, I want the cos x as a denominator, so I'm going to leave this. I won't expand because I see that I have a cos x. Okay, let's do, oh, I see, beautiful, I see my answer already. If you check, cos squared x sine squared x would give us 1, so 3, check, cos squared x plus, now plus 3 sine x. I only factorize those, and I still have that. Now sine squared x plus cos squared x will give us 1, so that remains as 3 plus 3 sine x over 1 plus sine x multiplied by cos x. What's common on the top? 3. 1 plus sine x over 1 plus sine x multiplied by, and you would see that that divides, cancels each other. 3 over cos x. So we must know how to work beyond calculators and walk through. Please take a picture for me quickly. Oh, let me see if I can. Okay, no, let me go to the next page to do that general solution. Talk to me, people. I'm not getting my pictures. Thank you very much. All right, so guys, you need to go over the whole thing again. And you can see this question alone, the total is 30 marks. So it is very, very important. 5.6, general solution. Sine squared x minus 3. Okay, guys, the rule is never ever divide except you are going to get sine theta over cos theta. Never divide except to get sine theta over cos theta. And I see that in this case, I'm actually going to get that. So what do? I'm going to move my 3 cos squared x to the right hand side. Now divide both sides by cos x. What do I have? Or cos squared x over. Do you see that? And that is tan squared x equals to 3. Now I would find the square root of both sides. Equation. What is tan x? It is plus or minus root of 3. That's where they want to catch you in this paper. Now, next job is to find my reference angle. Now, guys, when I find the reference angle, I don't use the plus or minus. My reference angle will be arctan of root of 3. And that's actually a special angle. That's a special angle. What's your answer? 60. That is a special angle. But in this case, let me show you how to get that in case you don't know. All right, shift 10 root of 3. Make sure you close the bracket. Oh, I didn't close the bracket. What did I do? What did I do? What did I do? 60. It's a special angle. So now, but I'm going to check. Look at this. For 10, put a small note there. Okay, let's do something. I want you to see something. Now, 10, I have both positive and negative. So we're saying either tan x equals to root 3 or tan x equals to... Now, please check. Where is tan positive? Positive in quadrant 1 and quadrant number 3. Where is it negative? Quadrant number 2 or quadrant number 4. But for 10, you only need to do one quadrant. So I'm only going to do one quadrant in here on the positive side, quadrant 1, and on the negative side, quadrant 2. Just to remind you, what is my reduction? In the first, it is the reference angle. Second, 180 minus your reference. Third, 180 plus the reference. And fourth, 360 minus the reference. Remember, all students take coffee. 1, 2, 3, and 4. So that's why I said tan is positive in 1 and 3. But for 10, I only need to do one of them. And I'll just do quadrant 1. So I'm solving for x. So quadrant 1, let's put it there. It is equal to the reference angle. So what is x? What's our reference angle? 60 degrees plus k 180, where k is an element of integers. We're done. Then I'll go to quadrant number 2. You don't need to do quadrant 3 for 10 once you have 1 and 3. Okay, what are we solving? X, what is our reduction? 180 minus reference. That's our second quadrant. So 180 degrees, our reference is 60 degrees, plus k 180 because of the period of 10. So what is x? 120 degrees plus k 180, where k is an element of integers. Case closed. I have my 5 marks in the bag. A picture, please. Questions if there is any. Question if there's any, let me know. Yes, can I get a picture? Thank you, Terofatu. Thank you, Nolwazi. Yes, that's what I want. Let everybody be involved. Okay, so we're done. You see 30 marks. Now we go to this question, 12 marks. You have 10 minutes on this. Trig functions. Come quickly. Okay, let's give, the time is only to sketch. Once you sketch, you're done. After this, then we do 2D and 3D. Come quickly. Let's go. Okay, guys, we're marking now our graphs quickly. Then we have a 2D and 3D. So you see that we're completing the whole thing. Now, the graph of f of x equals to cos x plus 30. You can see the graph has shifted towards the left-hand side. All right, between 120 and 150 has been drawn. Write down the period. Period has nothing to do with the shift. My period of a cos graph is still going to be 360 because my k is 1. So number 1, period is 360 degrees. You must know how to work that out. Okay, number 2, write down the range of h of x. If, I love this one. They said f of x plus 60 degrees plus 1. What would that be? It means anywhere I see x, I should say x plus 60. So it's going to be cos, my x has been replaced by x plus 60. Then I still have a 30 degrees to it. And then the plus 1 is outside. This becomes cos x plus 90 plus 1. And what is 90 plus x? That is negative sine x. Do you remember that? Anytime I see a 90, the trig ratio should change. And cos 1 plus 90 would be equal to what? Negative. So, negative sine x. What am I looking for? I'm looking for the range. Beautiful. Now, the minimum, our range is always between us the minimum, less than or equal to y, less than or equal to, and the minimum of sine x. Okay, we didn't really need to do all of this, but it's fine. The minimum of sine is negative 1. So I'll substitute negative 1 there and say negative 1 plus 1. Let's see what answer this would give us. This would actually give us 2. And then the maximum I'm expecting should be what? That is positive 1 plus 1. That will give us a 0. Okay, beautiful. Smallest value is 0. And the biggest value is 2. So the graph has been shifted 1 up. So the x plus 60 is a horizontal shift, but the plus 1 is a vertical shift. Minimum used to be negative 1. It has come to 0. Maximum is 1. Oh yeah, you can actually see it from here. Look at the graph, because my x plus 90 is only shifting horizontally. 1 becomes a 2 up 1 unit. That's the plus 1 there. And negative 1 up 1 unit becomes a 0. So it's between 0 and 2. Oh, 6. I actually answered 6.3. All right. I've already done with 6. This would now be my 6.3. Write out the equation in the simplest form. So this is my 0.2. And I showed you the process. And 3. Draw the graph of h of x on the grid provided in your answer book. So we're going to draw it over this one. H of x. What are we drawing? Remember, this is h of x now. So h of x is, and you would see something nice. It's actually the same graph, but shifted. Okay, is it the same graph? No. Reflected and shifted. Now let's do this together. Noku, my secretary, you remember? What do we do? Mode, table, negative sine alpha x, we close the bracket, plus 1. You guys remember this? Where are we starting from? Negative 120. Where are we ending? 150 as given. Now look at the graph. You have a step. We can actually use step of, in this case, I can simply use step of 90s. But let's use step of 30s. The 30s would not really make a difference. 30s, because we're given that on the... There we go. There we go. All right, who's helping me here? I need those values. Ah, sweet child. Come, Noku. You're such a darling.
Okay, minus 120 equals to 1,866.
All right, which is about almost 2. Okay, 1,86. Talk to me. Go on.
Negative 90 is 2.
Lovely. Negative 60.
1,866.
All right. Negative 30.
1,5.
1,5. 0.
1.
30.
0,5.
Lovely. 60.
0,133.
0,133. Are you sure?
Yeah, it's 0,1339.
Okay, all right. 90
is 0.
120. 0,133.
1.
And 150. 0,5. Lovely. And then you sketch your graph. Thank you, Noku. I see a beautiful point of intersection there. Shade that graph, and that will be my graph of what? H. We're done. How many marks? 3 marks. I make sure you have a turning point and intercept on the graph. That shows you that your graph is correct. Beautiful. We're done. Now use the graph to answer all the following. Where F is a minimum. Where is F a minimum? Let's answer quickly. Once we sketch, where is F a minimum? Number 4. Oh, we're done with number 4. Number 4 was the sketch. 5.1. F having a minimum value. The minimum is at -1. So X is equal to 150 degrees. I don't know if that makes sense. This is the minimum value. Okay. Number 2, 5.2. This one is where learners struggle a lot as well. Okay. H of X multiplied by, I told you to interpret from the right hand side. Less than 0 means I have a negative. It means this must be positive and that must be negative because I'm multiplying. Or when this is negative, that must be positive. Both will give me negative answer because that is less than 0. Right. But they also said equal to 0. Where would it be equal to 0? It's either this is 0 or that is 0. So I'm looking for any of these combinations. Let's go to our graph quickly. Remember, H of X is simply Y. I'll use a blue for the blue. Do you notice this is all positive across? It doesn't go below the x-axis, so it is all what? Positive till end. Okay, I'll use a red for this one. It is also positive. I don't need all of this. I don't want where they are both positive. Okay, by the way, it's 0 there. All right. Again, it becomes 0 there. And then negative, negative, negative. I'm looking for the zeros and the opposite signs. Let's get our ruler just to guide us. I'm starting from there. Do you see the first thing I see? 120, I have a 0. So that is going to be one of my answers. X is equal to negative 120 for 5.2. Then we continue. Both of them are positive. I don't need that. Where do I have a 0 again? Oh, there. And you will notice between 60 and 150, the sign changes. Do you notice? At 60, that's a 0. At 90, that's also a 0. That's important. I almost, because my graph, I didn't draw that graph very well. It turned there. That's a 0 for the blue. Okay, watch this. The red is negative, the blue is positive. Yes, I need that. Then I need that 90 equals to, then it continues. Oh, so between 60 and 150. Between, don't forget, between 60 and 150. So I'll come and say that between 60 and, but we notice that at 60 we have a 0, so 60 is there. Then at 90, I can just write that out. At 90 again. At negative 120, we have a 0. At 90, we have a 0. At 60, we have a 0. And all of those are taken care of. I hope you see. At negative 120, we have a 0. 90, we have a 0. At 60, we have a 0. Then between that and 150. Oh, wait. 150 is also inclusive. Please always check that. Why am I saying 150 is inclusive? It's not a 0 at that point. At 150, H is positive and the red is negative. Why am I including it? Look at the domain given. So 120 inclusive, 150 inclusive. That's why I am including that. Without that, we will have wrong answers. Are we okay? Am I getting a picture quickly? Oh, 6.5.3, where they are equal. That's just where they are touching each other. Where are they touching? They're touching at 30. And that's it, 30 degrees. Please send me a picture. Send that on the group. Beautiful, thank you, Tsehofat. Now, 2D and 3D, 7 marks. I know it's 8 o'clock yet, but come, let's just do this for, I want you to try, do this for 6 minutes. Let's see what you will do. 2D and 3D is what we've been doing since, so here is where you prove ourselves. 7 minutes. Two D and 3D. You have your notes there. Okay, guys, let's answer the last part of our trig. In the diagram, VP is equal to PQ. Okay, let's label it. VP is 5, which is also equal to PQ. I would just put my 5 there to make it very easy to see. Okay, and RQP is equal to S, which is SPV, which is alpha. Okay, that's given. We have our beta there, and those lines are parallel. SV is perpendicular, that is 90. Okay, so everything is there. Now, guys, when I come to this section, I always try to split my triangles. No matter what, it's going to be a lot easier. So let's split the triangles. Let me split them here. I have a right angle triangle, which we would refer to as triangle number 1, S, V, and P. I have a 5 there, and I have an alpha there. I have a second triangle, which is S, R, P, and I have that as a beta. Then I have a third triangle, okay, let's make, okay, let me just freehand sketch it. Which is P, R, and Q, and that's alpha. This is also 5. PQ is 5. Okay, so call this triangle 2 and 3. Number 1, express PS in terms of alpha. Let's go check. Where do we have PS? Oh, PS. In terms of alpha, and we have alpha there. Oh, that's lovely. That is lovely. Now, because it's a right angle, that becomes opposite, and hypotenuse, and that is adjacent. I'm working with hypotenuse and adjacent, and that is a cos. So number 1, cos alpha is adjacent over what? Hypotenuse. We want SP, PS. So PS will be what? 5 over cos alpha. We are done with the first question. 1 mark there. Once I see a right angle triangle, remember, I'll bring in my SOHCAHTOA. Number 2, determine RP in terms of what? Alpha and beta. Where do we have RP? Let's go check our splitted diagrams. RP. Oh, they want it in terms of alpha and beta. By the way, do you remember I have PS? Okay, so let's come and write our PS there. It's 5 over. Oh, and I think I already see my triangle. Do you notice everything they want? They want RP. I have it here. In terms of alpha, I have it here. And I have beta. So we can work with this. The question is, what rule are we going to use? What do we have? Oh, easy. Let's see. I'm looking for that. I'm looking for that. What do we have? We have sides and that opposite angle. By the way, let's check something. Why did they give us these parallel lines? We have fun angles, right? We have fun angles. Fun angles. They are supplementary. Okay, let's see something here quickly. Do I have angle R? No. Do I have angle S? No. Okay. But if I'm using, because I want to make sure, if we use cosine rule, all the 3 sides will be involved. I need that side, I need that side. Because you have A squared, B squared, and C squared. So let's see if we can get one of these angles, and we'll play around with it. Co-interior. That angle is 180 minus alpha. Just want to see something quickly. Want to see, am I missing? Yes?
The angle R, that PRQ is equal to beta because alternating angles.
Okay, yeah. So this angle here would be beta. Okay. So which makes this angle 180 minus, just let's feel everything we can feel. Okay, let's see something here. All right, so let's feel all the angles we can feel. R is now please watch the R that is beta. It is PRQ. So PRQ, which is probably shifting my, okay, that is what beta. And we have, okay, let's see. We want RP. Oh, RP is also here. Do you see RP there in terms of alpha and beta? Lovely. So we have two triangles, but we have to find the one with more information that will help us. Now, if you notice this one, we have angle, opposite side, angle, opposite side. So we can simply use sine rule from triangle number 3, from triangle PQR. Sine beta over 5 equals to sine alpha over what? PR. Cross multiply, PR sine beta. So both triangles have information, but triangle 3 helps us better. Beautiful question. 5 sine alpha over sine beta. That's why drawing out the triangles just makes a lot of sense. Number 3. Number 3. Hence show that the area of triangle RPS. The examiner wants area. We have two formulas for area, remember? We have half base times height if it's a right angle triangle, and we can use half AB sine C. But let's see the triangle. Let's inspect the triangle. RPS. RP. Okay, it's not a right angle triangle. So triangle number 2. I have to use half AB sine C. But now, very important, we need to see which side do we know. Oh, by the way, we know RP now, right? Lovely. Oh, I see. Now we know RP. So it is this side, and the angle between them. Half, first side, SP. So please know the rules. Sine of the angle between them, beta. Okay, come. Half. What is SP? That's the first thing we got. 5 over cos alpha. What is RP? The one we just got now. 5. Oh, I see the 25. And I also see the 10. Multiplied by sine. The sine beta cancels the sine. 5 times 5 would give us 25. What do you notice? Sine alpha over 2 cos alpha. And what is sine alpha over cos alpha? 10. And we have the 2. Done. Know the rules, know the usage, case closed. Guys, did you enjoy the whole of trigs? That's the whole of trigs. Complete trigonometry now done. Please watch the lesson again. Use it for your test. Use it for assessment. This is complete trigonometry done right across. Oh, did you get a picture? Sorry for the extra time, but I think it's worth it. Got a picture? Okay. Have a lovely evening, everybody. Have a lovely, lovely evening. Lesson is available on the playlist. Okay. I'll make this lesson open to everyone. You can share with your friends and every other person that you want to help, that you like. Good night. And I'll see you next time.